tips, hints? Oh. Someone say something? Okay. For question one, so this is dealing with similar triangles. Now, we didn't go through this yesterday in any revision, but remember, similar triangles is all about how much one is bigger than the other. Is one 2 times bigger than the other, 3 times? How you compare is you look at two sides that you would know, definitely the lengths of, and then compare how much bigger one is by the other. But it has to be a multiplication, not just an addition. If you want help with that, maybe go to page 376 in your books. Calculate the exterior angle of a regular polygon. This is what we did yesterday, so it should be pretty straightforward. If you're unsure, I'll have the video up of that lesson later, but if you want to do it now, I would go to page 117 from your books. Next one. Okay, so this is area and perimeter. Remember, if you're calculating area or perimeter, make sure you include the missing sides. So here and here would want to be included. And if you're calculating the area, split it up into 2 shapes. So you can split it here, you can split it here, because there is no formula for the shape that's given. So you just use area of a rectangle. If you need help with that one, perhaps you can go to maybe page 218 from your books. Okay, water tank. This is volume. So volume, remember, make sure everything's in the same unit for this one. So we've got meters and centimeters. You have to convert them all to the same unit. You can choose. If you need help with it, go to page 259 from your book. Okay, when I say page 259, that's where the help will start. And there'll be more examples on page 260 and 261. So, but that's the first page that you can look at, and you can see some examples there. And same for all these page numbers. Next question. Okay, so this is similar to one that you had for homework due for yesterday. Chinara, you missed the meet yesterday. I was looking for you, so hopefully you did that homework. We went through how to do these yesterday in class. So it's tricky. You need to have knowledge of isosceles triangles from page 111, and you would also need to know some angle properties from page 105 for this one, so if you need help. So remember, if you want, you can continue these lines, so you can look. So for instance, this is the same as this, and stuff like that you can do. Okay, so you can continue those lines to find x and y. All right, so this is more of the same pages. This would be angle properties, so the same pages apply to these. For A and part B. This one down here, the interior angle, which is something we did yesterday as well. That's on page 117 if you want to review that, or you can watch the video that I'll post later. For question 5 then, it's back to similar triangles. So once again, it's the same thing as before. How do I get from here to here? What do I multiply by to get from 8 to 20? It's not going to be a whole number, it's going to be some kind of decimal. To figure out how to do that, I again refer you to page 377. We did it last year, if you can remember. Question 6 then. Okay, so you're probably able to, we did that in the online lesson. You can check on that on my YouTube if you want, what type of angle that is. And writing down one side of the equilateral triangle. Check out the YouTube video for that. For the lesson, and once again, similar triangles, so you can see it's quite a common question. So go to page 377 again, and we will run through that on Monday's lesson about similarity and all the answers to these. Okay, so the first question, question 7, is actually a fractions question, but sometimes they mix them up. So fractions is from the last unit, you should be able to do that. This is a volume, so this is a tricky one, but you get the formula for the volume for this. You will get that on page 260, I think, or 261. We'll just have a little look for volume of a cylinder, and you have to do it in 2 different sections. So do the top section first, and then the bottom section, and then add them together. This one is a bit like the ones we did yesterday in class as well. So we know that 3 angles add to 180, so form an equation with the 3 of them added to 180. So the first one plus the second angle plus the third angle added to 180. So that'll be the equation you form. Simplify it, add the x's, and then start to solve. It should be a 2-step equation. All right, moving on to question 9. So this is trapezium. So you can use the formula for area of trapezium, which you'll find in the, I think it's on page 219. Even if you're not sure about that, you can split it up into a triangle and a rectangle if you want. So you can just get the area of this rectangle, but remember to take off this little bit. How much is this? You can probably figure it out because that's 120. How much is left here? Then multiply to get the area, and then base times half base times height will give you the area of that. So you can do that using either the trapezium formula or just a triangle and a rectangle. And then this second part, show that AD is 95. That's actually trigonometry. So they mixed up trigonometry, and that's you're going to have to use Pythagoras' theorem. So if you can remember that, maybe go to page 202 if you can't remember how to do that from last year. Most of you were able to do that last year, so I think all of you were able to do that last year, so that shouldn't be an issue. And then this is kind of a problem-solving question. Just you'll have to do. Remember, it's in 5-meter sections, so you have to break down it into 5-meter sections when you do get the perimeter, which is the outside bit of the shape. Next one, you'll have to draw a net. Okay, so if you need help drawing nets on this diagram, nets of shapes will be covered around page 252. Focus. Around page 252 if you need help with that. But remember, a net is an unfolded shape. So in general, if we have a box like this, it's a 3-dimensional box. The net of the shape will look like, okay, this is the bottom. So we did this last year with the Coke can, if you remember, and we have something like this. So remember, the net is going to be a bit like that. In the question, they do say that it is an open box, so we do not need the lid. So there'll only be this bit on top would be missing. So you do not need to include that 6th side. So you need 5 sides for your net. All right. Draw all the lines of symmetry. So that's where you can fold it. You probably don't need help with that. But put dotted lines, so where you can fold it. So for instance, a line of symmetry on a triangle would be down here like that, because we could fold it across there. If it's equilateral, you'd have more. But if it's just an isosceles triangle, which this one I tried to draw, it would just fold down here perfectly. How many places can we fold a rectangle perfectly so it folds on top of itself? Interior angle of a hexagon. So once again, that's from yesterday's work. If you need help with that, about page 118. This is just areas again. So remember, split an area into this one, probably split it into 3. You can split it here, here, or maybe here and here, and just do areas of a rectangle, length times width. This is isosceles triangle. Key to this would be use this straight line here to start off with. Find this angle first. You should know how to do that because 180 degrees is a straight line angle. Question 11 and 12, I think, are the most, maybe 11 and 13 actually, the most difficult ones. So this is about a hollow metal pipe. Tricky, but we need to do areas of circles and stuff. Remember, the area of a circle would be pi r squared, pi times the radius squared. So you need to figure out the radius and maybe subtract here to work out the shaded area. The volume then would be a tricky question, and that's check out page 259 up to about page 26, up to about 264 for examples of how to do volume. We still have yet to review volume and area. We'll do that, don't worry, next week. And the curved surface area, okay, so surface area, that's going to be a difficult one as well, but on page 251 up to about page 257 has some examples of how to get a curved surface area of a cylinder. So look for curved surface area of a cylinder. It's a formula that you might have to use. Question 12. All right, so calculating BC, that's one of the short sides in Pythagoras. So you have to use Pythagoras again, which around page 203 has some examples for that. And he puts a fence around so that's just the length of the fence. So that's just perimeter of the shape. So that's the distance around the outside. So you can figure that one out, hopefully, once you have the length BC here. Last question then is on circle theorems, which we did last year, but you probably don't remember that well. That's okay, they're in the book for reference from about page 489 up to about page 493. You can check that out in the book if you can't remember. This is a tricky one, we do need to go over this again. So write down the mathematical name for DE. So DE is a line that just touches a circle slightly. I wonder, does anyone remember what that is? On the circle, just draw a radius. So the radius would be from where to where. Just draw it in on the circle and point to it with an arrow. Complete the following statements. The angle ABD. So if we're looking for the angle ABD, remember that's the angle at B between A and D. So at B, here, at B between A and D. So that's that whole angle there. So what angle is that? And it's about the tangent to a circle, what angle it makes with the center. So you have to figure that out using maybe the circle theorems. And then ACB, so C is in the middle here, so it's this angle here, is that one. Why is that? Well, I'll tell you, it's 90 degrees, but can you tell me why? And then you'll find the reasons why on this page. So you have to write something. And the last one then is calculate the area of a circle. So that should be just pi r squared again, the area of a circle. And calculate the length BC, which on your diagram is from here to here. You're given what AB is. Can you figure out what BC is? That you know that that's a 90-degree angle. That's a tricky trigonometry question to finish. If you need help with that, I think on page, from about page 333 up to page 344 has some examples that might be able to help you there. That's the tricky question to finish. This unit doesn't fully include trigonometry yet, but there can be little bits of trigonometry in it sometimes because trigonometry is trig geometry. It's geometry. It's got to do with triangles and rectangles. So we need to know a little bit of trig. So you definitely need to know Pythagoras' theorem for this exam. So that's something that I referred to before, and Pythagoras' theorem will be on page, about page 202. So make sure you definitely know that. Now we'll be doing it in class anyway before the exam. The exam for this, by the way, is at the end of November. So you still got a month to go before that, but we'll get through all the theory for this. But this is just a general overview of what exam questions look like, and maybe it's okay that I'm not marking you on this homework, but do complete it, please, for Monday's class. And try as much as you can. Refer to those book pages. I'll stay online here if you have any particular questions. If not, just use the time wisely and try and get as much of it done today as you can. It shouldn't take any more than an hour to complete. And then you won't have any other homework other than this. No Maya Maths homework beyond what Miss Whittian said last week. Any questions?